Okay, I want to use today's time to talk about 4.7.1 example. This question is very similar to two of the homework questions that assigned last week. The first assignment last week was chapter 4. I wasn't able to find any question on Webwork, so I assigned the textbook questions. Now, question, I think it's 1, 2, 3, 4, 5, 6. Basically, it's number 4 and number 6. They're both similar to example 4.7.1. The first one is similar to 4.1 about calculating the accumulated value, which is also future value of the cash flow. Then the last question is calculating the implied rate interest rate for the 20-year period. All right, so since it's similar to example 4.7.1, it's best to understand 4.7.1 and then using that as example. If you look at these two questions, this is the homework assignment and the textbook. This is 4.7.1. So 4.7.1, the example in the textbook is saying that we got deposit of 1,800 at the beginning of each quarter for 15 years. Nominal interest rate is 6% convertible monthly. Now we're using a thinking fund method. We have the principal in one account and we have the interest in a separate account. So the interest from this fund is paid out monthly and can only be reinvested at an effective annual rate of 4.2%. That is monthly, so you have to convert the 4.2% into a monthly interest rate. Find the accumulated value of Barbara's investment at the end of 20 years. You see the difference? That means after the 16th year, there's no more, after the 15th year, there's no more cash flow. But the money is in there. So even though there's no more actual cash flow, the money sitting in the account, it will still be earning interest. So we still have a cash flow of interest, the same money sitting in the account for 5 more years. By the end of 20 years, we want to know the future value of that. And we also want to find the new effective yield for this period. So that will be the other question, the implied interest rate calculation. So first we calculate the accumulated value, the future value. Once we have the entire cash flow, the combined cash flow, then we can then look at the implied interest rate. So let's look at the accumulated value first. The textbook does explain it fully. So if you follow example, it's looking at these two cash flows separately. One cash flow is a deposit, and this deposit is being paid every quarter, beginning of each quarter. So we have at time 0, that means 0 quarter, we have 1,800, and the same amount for it's quarterly payment for 15 years. So if you take 15 quarterly, 15 times 4, 60. So we have 60 payment. The first payment is at the beginning at time 0. The last payment is at time 59. Then after that, for 20 years, 20 times 4 is 80. So the time period is 80 quarters, 20 years, but 80 quarters. So we're marking out the timeline using how many quarter it is. The time point is given by number of quarters. At every time point, the cash flow is being given. After t equal to 59, there's no more cash flow. So try to understand the cash flow, and then we can sort of look at what's going on. And number one, that we're not letting the money sitting in this account earning interest rate. We're actually taking out the interest and putting it in a separate account. That's the account this is a second account. This account actually earning a 4.2% annually. So not the 6%. No, but the interest from the first account is being paid out to the second account. So when you're calculating interest value, you still have to use the interest rate of 6%, but you, since it's paid out monthly, you have to find the monthly interest rate. So you take the 6% divided by 12. Well, since it says convertible, so we divide it. So this is a nominal interest rate. And this is the actual, if the annual interest rate, so they're not the same. 6% divided by 12, that is a monthly interest rate. So with a monthly interest rate, we multiply by the principal to find out the interest. So 1/800, if you multiply by 0.05 each month, we're getting $9, at least for the first quarter. So between 0 and 0.25 and 1/4, the interest is $9 per month. Remember, the 6% over 12 is a monthly interest rate, and it's being paid out monthly. So we have $9 for the first month, $9 for the second month, $9 for the third month. And then starting at time 1, I mean, when the time 3, that is months. So the second account, since this cash flow is by months, so we mark out our timeline by months. But our interest is being calculated by quarter. So this is a payment more frequent than interest kind of thing. But then you can look at t equal to 3 months, that's 1/4. So it's t equal to 1 in the first timeline, but t equal to 3 in the second timeline. By the time you reach here, the cash flow change, the interest change, because now you have 1/800 plus 1/800 in this account. So the interest that should be paid out for the first account will be 3,600 times 0.05, and that's double the interest. So now we have $18 interest for the second quarter. So month 4, month 5, month 8, the interest is $18 per month. With the same reasoning, you can see that every quarter, the value of the interest change for the monthly payment, it changes by 9. So 9, 9 plus 9, 9 plus 9, 27, 27 plus 9, 36. So increment is 9 in the second cash flow. In the second cash flow, the time is being marked out by number of months, and we're looking at a monthly payment of cash flow. Since after this 180 means 180 months, and that's a 60 quarter. After that, the interest stopped growing because the principal stopped growing. This is all the money that we had, and the principal is 1,800 per quarter. Since we have 60 quarters, so 1,800 times 60 is a overall principal. I guess it's calculated over here. 1,800 times 60. That is the principal. So we're looking at a calculation of principal and the cumulative interest at 2 separate calculations. So the first timeline allow us to figure out the principles, which is 1,800 times 60. The second timeline allow us to calculate the accumulated interest. So first you mark out your cash flow, and then you want to find out the future value of all these cash flow. We want to know when t equal to 240 months, what was the accumulated interest then? So this calculation is not as simple because you can see the cash flow change as in increasing order, 3 at a time, and also as after 180, we stop having an increase of the interest. So they are all 540 as far because the principal is steady. So the interest becomes steady after the t equal to 180. Okay, so since the principal calculation principal is no problem, that was a 108,000, which is calculated by 60 times 180. Our most of the effort is on calculating. I hope I'm recording. Most of the effort is on calculating the interest. So you're going to calculate the future value of all these cash flow. The calculation, we actually have a formula in the book that is increasing payment, 60 increasing payment, um, the change is every 3. So every 3, it would change. And then this is a calculation, and that is giving us the future value. IS is increasing payment, the S is a cumulative value of increasing payment. So this calculation allow us to get the future value at time 180, or you can also say at time 60 quarter. So that's the future value at this time point. So to find the future value at t equal to 80, you have to let it grow. You have to multiply by accumulated growth factor 1.45 to the power of 5. That's 5 years. So at t equal to 60 or t equal to 180 on this timeline, that's 15 years. And then you let it grow 5 more years to get t equal to 20. So at t equal to 20, this is the total future value. And then the rest of them is from 240 minus 180 is 60. So we have a 60 payment of 540. So same payment, repeated payment of 540 for 60 times. The future value is being calculated by 540 times S60, and the J has to be the monthly interest rate. 60 payment of 540. It's a monthly payment. So that's why we got to have the J calculated. J is equal to 1.42 to the power of 1 over 12 minus 1. That is a monthly interest rate. And the first calculation is I is a quarterly interest rate. So you calculate the quarterly interest rate with the 4.2 being the annual interest rate. That's the calculation for I. Now this part, if you look it back up in the previous section, IS, we have a formula for IS in chapter 3. We also should have one already in here that we're applying that formula already given in this chapter. It was similar to this is a present value calculation, but we're calculating future value. So it is this. Yeah, this is the formula we're applying. We're applying 4.5.8 in the future value calculation of the increment payment. Now, if you look at it, the timeline that we have here is similar to the one that we have in 4.7.1. So if you have a $1 interest in the first interest period, let's say then our first interest period is being separated into 3. So this should be like 1 over 3, 1 over 3, 1 over 3, and the total equal to 1. Okay, so this is similar to the timeline that we are seeing in 4.7.1, except our cash flow is not $1. It is actually 999. It's actually $27. So this 1 is becoming 27, and this m equal to 3. So 27 over 3. Or you can think of it as find out the future value here, but then multiply by 27. So all these, once you find the future value, which is this one, formula for this one is this, or we see 4.5.8 formula is what we're using. And then we got to multiply by 27 because the cash flow in one interest period is not $1. It is actually $27. So going back to the 4.7.1 example, you see that's the reason that we have to multiply 3 times 9. So we have 3 times 9, and then we apply IS formula to get that repeated cash flow inside the interest period, that kind of situation. And so this is a total amount. If you want to look at even more detail of the calculation, I can work it out over, let's open a separate, so they are not covering each other up. Okay. it's where yeah, so this is really the formula part of it. If you want to see how it's being calculated, you can use the BA2 plus calculator, or you can use a manual formula for the computation. Then let's try to use the formula first. All right, so I did some calculation myself. The I and J is already being given. Oh, it moved. The J is a monthly interest rate. The I is a quarterly interest rate, if that makes sense. Then I hope I didn't really mess it up. So let's work out the calculation. So number one, let's calculate IS 60 I and then 3. This is already given in here, but it doesn't really provide details. So if you want to know how those numbers coming from, I can try to explain. First is the 9 times 3 times 1.45 to the power 5. So if you can take 9 times 3 times 1.042 to the power 5, that is equal to this. You can use your calculator to double check what happened there. All right, yeah, that is equal to the 33.16670737. I'm trying to keep as many decimal as possible because accuracy really changed the final answer to a question. Now this one, it already have a formula in the text. So the formula is the one, what did I, doesn't allow me to move. Okay. Then it should allow me. Right. So this is equal to, according to the IS increasing payment future accumulated value is being calculated by, well, already you have that. It's the S future value for annuity due. And this is 60 I minus 60 divided by I 3. And then this calculation is equal to, and then you see there is final number already, so that's the part maybe it's skipped. This calculation as 60I is, we got annuity, chapter 3 on annuity already practiced. I hope that you still remember how is that being done. Now, the actual calculation, I did it myself. It was this part is calculated by oh, let me separate that calculation there. So S60I, now the I is given by the quarterly interest rate. That's the future value is being calculated by, that's the immediate due. So the immediate due is the future value, one time period, one interest period of the immediate uh, annuity immediate. So this is 1 plus I times S60I. That's kind of the thing. I memorized S60 and did not memorize the 60 double point. So the I is given by the 1 plus 4.2 to the power of, that's a quarterly interest rate, to the power of 1/4. So if you plus 1, it become 1 point, I guess it might be easier to type 1.042 to the power of 1/4. And that's the 1 plus I part. All right, and then the S60I is I to the n power, n is 60, so it's 1 point. I might be doing a lot slower than you guys did. So it's 1.042 to the power of 1/4. That's I, but I has to raise to the power of n, and n equal to 60. This is a minus 1. That is a numerature. And this is divided by I, and then I, the capital I is the 1.042. It's 1.042 to the power of 1/4. And that minus 1. This, I don't have a lot of decimal marked out, but in my notes, it was 83.418. All right, but you can also double check this number using the calculator. If you use a BA2 plus calculator, this is a repeated payment of $1. We want to, if the $1 is paid starting at time 0. So if you're using your BA2 plus calculator, first you're gonna have to set it in begin mode. So set it in begin mode. I think my calculator. So second, and then payment, and second. So now that's set it in begin mode. Once your calculator is in setting begin mode, and now what you're gonna do is to have the payment. So $1 for the one for payment. And the number of payment is 60. That's N. And then the interest, we have to find the interest. So let me calculate interest. I try not to mess it up. So it's 1.042 to the power of 1/4. So 0.25 is a power minus 1. That was the interest. So I'm gonna add interest as, this is our interest. So interest is, that you enter as your interest per payment period. And we want to find the future value. So we make it 0 as our present value. And then K in calculate the future value. That should provide our final answer. Let's see. Let me try it on my calculator. 1 for payment and 60 for, try to double check if it's the same. 60 for N. I think I forget to add the point for the interest. So it's 1.03385,633 for interest per year, and 0 for the present value. And I'm going to calculate future value. Yeah, so with that, you will find out that the calculated future value is 83.4. It's actually negative because you have a positive cash flow. To balance the cash flow, it will be negative future value, but for us, it doesn't really matter. So it's 83.418 A16534. So calculation like this, you can do it with your calculator, or you can do it with a formula. Back to the question here. So now we know that numerature is going to be the, I should copy it, 83.41 A16534. And then that's gonna minus 60 and then divided by I. Now I, it is already given here. It's already given. I is a quarterly interest rate. I've been talking about it. No, divided by I3. I3 is 3 times J, and J is a monthly interest rate. Now, this is really applying the formula that was given by the book. May not be the best one, but I do try one other method. 1.042 to the power of 1/12. This is a monthly interest rate. And then minus 1. Okay, so that is what we mean to calculate. For this, we're getting, let's hope we get the same answer as in the book. I'm trying to review and try to see if we got the same thing. So this calculation give us a future value of, so we're getting this number. All right, so that's the IS part. And then this IS part, you also have to multiply the 9 times 3 times 1.45 to the power 5. So with that calculation, we're getting a future value 1 that is equal to, see, 9 points. Oh, we should copy it. 33.16630.737 times the 22. Let's see if it copy. All right, and then these two multiplied together is what's the calculation, and that is the same as you see in the book. To get the first future value, and you see the one in the book. It's 75353513411344. What we're getting, well, there's slight differences because of rounding error. Because even though I try to keep as decimal as possible, I did round. So that's the first one. That is a cash flow that goes 999, 18, 18, 18, 27, 27 until the 180. 540, 540, 540. So that's that part of cash flow to find its future value at t equal to 240. We also have the repeated payment of 540. From 180 to 240, there's 60 payment of 540. That you gotta calculate its future value using the future value accumulated value formula. This is this one. So for that one, we get this number. And that means that you can see how it's being calculated. So let's not repeat that part. We can call that the future value number 2. All right, and then we can combine them together. What happened there? After we add it together, it's this is the total value of interest. So future value of interest, it is equal to future value 1 plus future value 2, which is this value. And we also have the principal, which that was the 180 times 60. If you take 180 times 60, it's equal to, well, I type it, it's gone. Okay. So the principal is equal to 108 000. So that's 1,800 times 60. That's how we get. And then you add it together. So then you can see here that's the accumulated value of 219 to 296 point. That was see. So adding this in future value of the interest together with the payment of the principal, that's the total accumulated value. This is what we have in the example. Try to save this. I can still trace them, so I don't have to type it again next time. Um, 4.7. All right, so it's there. So next time we can come back and without typing it too much. Now let's do the same thing for our example. Well, I mean to calculate. This is the textbook way, and we can also calculate it without the textbook. um, I tried it without the formula, and as you can see, I'm not that good with memorization of the formula. I try to remember as little formula as possible. So this is our cash flow. So I can put it over here for the time being. Gotta make it take up less space. Guess this could be to the side. I don't have enough space to display the cash flow. All right. What happened? It's gone. I want to try to explain how I did it the other way around, and hopefully this method takes less space. Right, so this is our cash flow. We can also do it without applying that formula, the black formula that I had up there. That is thinking of the actual future value. And you can think of these payment of $9 per month. And we can combine them and make it the way that their value is a single payment in here. Okay, so in that way, and then the total at times 3, what's their total future value? It will be the same payment, right? It's kind of like a simple annuity. So it's gonna be 9. Their future value is S, and there's a 3. In this case, it gotta be the monthly interest rate. We were using J for the monthly interest rate. And J was equal to, J is the monthly interest rate of 1.042 to the power of 1 over 12. This is a monthly interest rate minus 1. There. So, and you can see that is this value. Now, if we try to find the future value of this, we got to go there and we have to find how many months in between here to the future value. So I think it's easier just try to go ahead, find the present value of this. So if you make 9 times S3J, and that will be a cash flow right here. Okay, so we can find the present value, like what the time zero value of this. So then this has to be multiplied by the 1 plus j to the power of -3. So that would be the future value of the first three, present value of the first three payments. And now plus, now what about the 18? So it's 18 times, again, if you want to combine the three payment of $18 into one payment over here. So all you have to do is pay S8 S times 18 times S3J because it's three payment of $18. 3S3J is going to be the total that you pay at time 6. You pay this much. It will be the same thing as paying 18, 18, 18, and add 4, 5, 6. And that is the, if you look at this 18 times S3J, that is the total value at time 6. But we want to find its present value of this three payment, and that will be 3 and 6. So then it has to be 1 plus j to the power of -6. So I'm trying to look at this payment. Okay, and then we can do the same for the 27. So following that, you will be, we'll have like plus 27, and then we have S3, S3J, write that notation. That's the immediate due of three cash flow, three payment of $27. That is how much you have to pay. If you pay 27, 27, 27, $27 as times 7 times 8 times 9, one by one, or you pay at time 9, you pay this much. They will be the same, they will have the same value at time 9. But this is going to be the time 9 value of all three payment, but we want to convert it to a time 0 value, which is going to be 1 plus j to the power of -9. Okay. The same thing can go on. All I'm trying to do is, instead of having this calculation or this calculation together with this calculation, instead of following that formula, maybe we can look at the equivalent cash flow. That allows us to calculate the present value or the future value of this payment of until this amount. All right, for the other one, I don't, this second cash flow, the future value to this one, I think it would be the same. I mean, same payment for 60, payment of 540, and then the future value is the same way. So that one we don't have to. This one we don't have to do any new way to calculate it. The first one, to me, it relied on a whole lot on the new formula, which is a bit of time consuming for me to go through. I mean, I don't know how that, but this way the way I do it, it's not that simple. It goes through some analysis of what's going on. The last one is a 540. Future value of three payment of 540 is S same S times 3J. You can see the S3J, S3 is same like a common factor to what we're trying to do. And so this is being multiplied 1 by 1 plus j to the power of, let's see how many of them. 3, 6, 9. So the value that we had is -180, I think. Yeah, for the 27 is 9. For the 18, it was 6. For the 9, it was 3. So for 54 divided by 3 is negative 180. That's what it is. Okay, now this, what we are doing right now, it is a present value calculation. And if we want to find the future value, the entire calculation has to be multiplied by 1.042 to the power of 20. Okay, now this calculation should have a value that equal to the 7535.1349, and that is, trying to double check if I do have the same value. Okay, so you can see, you can bring out the common factor, the S3J. We can actually calculate it. That way it's S3J. If you pay $3, you pay $1 3 times at a increment of time. All right, according to our formula, it will be 1 plus, this is the future value, so it's 1 plus j to the power 3 minus 1 over j. Right, and it will be something close to 3, but if the future value of 3 should be a little bit higher than 3. So we know that j is this one. So if 1 plus j will be the 1.042 raised to the power of 112 raised to the power 3 is 1/4. Then this minus 1, and this is over the j. J is going to be 1.042 to the power of 1 over 12, and that's minus 1. This calculation looks funny. We can then calculate it. The answer is, try to pull a calculator. 1 point. You can also use your calculator to do similar calculation. I don't know, did I made it more complicated than it was before? 1 over 12 and minus 1. Right, so slightly higher than 3, so this is what we have. We're going to use this later. There. Okay, so then we can look at all the other calculation that we got here. So this calculation, we have to try to think of an easier way to do the computation. Now, let's use a new notation. Suppose A represents 1 plus j to the power of negative 3. And then let's say S represents the S 3, the future value formula S3J, is writing it multiple times seems to be time consuming. So with this notation, this calculation become this. Let's try to simplify it. And it's going to be 9 and then S and then A plus 18 SA to the power of 2. and plus 27 s and a to the power of 3. So we kind of try to use the calculus to simplify the computation. So then last one's 540. S is at 3.0103 number. S is a number, and A is also a number, but right now 180 divided by 3 is 60, so the power is 60. And then on the outside we have 1.042 to the power 20. And we can think of some of the common factor. We factor the common factor out, which might make the calculation a lot easier. For example, we can get 9 and then S and A, and then what do we have left? If we factor that out, we have 1 plus 2A and plus 3A square, 3A square, and so on. And so you can see there's an increment here. If you bring this 3 out, this is going to be 60. Bring the 9 out, it's 60. As A gets out, then we have A to the power of 59. All right, and then this is multiplied by 1.042 to the power of 20. So the calculation becomes slightly easier. And then you can see we have S value for A, and it's not so hard to find the value for S. S is already calculated. A, 1 plus j to the negative 3 power. That is not hard to calculate either. So 1 plus j is a 1.042 to power 1 over 12 minus 1. If you plus 1, it's going to be 1.042 to the power of 1 over 12 times negative 3, which is negative 1/4, negative 1/4. That's what A is supposed to be. Anything else? So the main thing left us for us to calculate is, I wonder if I'm using too much time for a single question. Just think out loud. So this calculation is now become a main issue, but that's a very typical calculus question. Um, and we can use a little bit of calculus to do the computation. That is, um, suppose you have FA, which equal to exactly what we have there, which that is a summation of, we'll just write it out, 1 plus 2A plus 3A squared plus 60A to the power of 59. You can think of this as almost like the derivative for this function. So if you go g of A, which is equal to like A plus A squared plus A to the power of 3, and then plus dot 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 plus A to the power 60. And then you realize that the derivative of g of A is f of A. Okay, so if you're able to calculate a formula for g of A, you certainly will have the derivative of it, which then you have a formula for f of A. Now this one using a little bit of geometry, this is a partial sum for a geometric theory, so it's A times, and then you have 1 plus A squared plus A to the 59. So that summation is 1 minus A to the power of 60. And that's divided by 1 minus A, right? So this is based on the geometry theory, partial sum for geometric theory. So that's the G of A. You can also try to combine them and become A minus A to the power of 61 divided by 1 minus A. right there. So once you have a division, once you have a formula for g of a, you can then have a formula for its derivative. So which would be the formula for f of a. Now, derivative of the function using quotient rule, it's a division, right? Quotient rule. Then we have the denominator is 1 minus a squared using the quotient rule. And numerator, there's like a terms. Some of the terms can be combined. We left with 4 terms. So it's gonna be what we have left is 1 minus 61 a to the power of 60 plus 61 a 60 to the power of 61. At least that's what I did after I applied quotient rule to the derivative calculation. So then I know how the f of a is being calculated after replacing the actual value of a. So a is what's in here, and that's really the f of a. Once you get f of a, you get that number calculated, and then you're gonna see this total summation. It looked like this. I guess let's try to make it easier to type it out. All right, so it's 9 times the A is 1, the S is 3.01031493283. Right, that's the S. And then we need to multiply A. A is 1.042 to the power of negative 1/4 or negative 0.25. So that's that one. And then this is going to be multiplied by f of a. And then we now have a formula for f of a. F of a is a division. It's 1 minus 61 times a. A is 1.042 to the power of negative 1/4. Then it's multiplied by 60, which makes it negative 15. And then plus 60 times a to the power 61. So it's 1.042 to the power 61. So it's going to be negative 61 over 4. Then this is multiplied by the denominator. Denominator is 1 minus a squared. And a is 1 minus 1.042 to the power of negative 0.25. 1/4, negative 1/4. And this is raised to the power 2. So that's f of a all done. And then we have to multiply by 1.042 to the power 22. So after you got the present value calculated, multiply by the 1 plus r to the power n, that should equal to the 7535.1449. But let's see if it works out. Okay, so that's exactly what the text giving us. And that's even more accurate than what I did. The reason that it's more accurate is because the reason that it's better because we have one sitting and we don't have to do rounding. We avoided rounding error if we do it this way. How come it won't let me open the OneDrive? Okay. Um, I was trying to type it up. All right. So this is example 4.7.1. All right, so this calculation is kind of useful, and we're gonna put in all the other number. This is what I called the future value 1, and then we know the future value 2 already is equal to 111,296.76. And if you want to know how it's being calculated, it's actually the 540 multiplied by the future value of the 48 payment. And I'm going to type it in there, so maybe when we apply to our example, it's easier. So try to get as much of understanding as possible for the question, for the example. Then when you look at your own question, there won't be as much difficulty. So let me type this up. 540, I guess we can make it larger so easy to view. And we want the size to be bigger. Okay, okay. All right, at least that's a little bit bigger. 540 times the future value of 60 payment. So that will be the 1 plus j to the power of, so this is what it is. It's supposed to be 1 plus j to the power of 60 minus 1. That was a numerator divided by j. That's what it's supposed to be. However, you know how j is? J is a 1.042 to the power of 1 over 12 minus 1. J is a monthly interest rate. And we're paying a monthly payment. Each month is 540. So this calculation, to make it more accurate, is what it is. This is going to be, so numerator 1 plus j is going to be 1.042 to the power of 1 over 12. So the power going to be 1 over 12. But then this j has to raise to the power 60, so that is 60. And then this is going to be minus 1, so that's all the numerator portion of it, divided by j, and then j is 1.042 to the power of 1 over 12, and this is minus 1. All right, this can also be done using a BA2 plus calculator, but I just want to have a way to combine them into a one-step calculation. All right, here we get that, and we can see, oh, that doesn't belong here. And that was the total. Where was it? Yeah, it's 3591169. I think it's, yeah. So this is what we get after we calculate this, right? And that is identical to the textbook solution. What happened? Yeah, so we would combine uh the future value 1 with future value 2, which is going to give us that. And then remember, we also got the principal, that was the 18,000 multiplied by the 60, and that's how we get 108,000. And then the overall total future value is going to be all of these added together. So you're going to add this one with this one. Oh, all right, and that's giving us the actual answer for the future value, or for the accumulated value, future value. All right, and that was the example 4.7.1, 4.7.1. All right, now let's look at our question, the homework question. We're gonna change a few value just to match our question. Make sure I didn't overlook anything. Our question is right here. You can see it's similar situation. We just deposit 1,500 instead of 1,800 for 16 years instead of 15 years. The interest rate is still 60%. The interest from this fund is paid out monthly, so it can be reinvested for effective annual rate of 5.2% instead of 4.2%. All right, so number one is we will be able to, let me try to use a different color. We will be able to use the calculate the principal. We're separating the principal into two different accounts. So the principal is 1500. How many payments? 16 years, quarterly payment, 16 times 4 is 64. So then we are able to calculate what is the total amount of principal we would be paying. Then that we can calculate pretty quickly. All right, so it's 9600. All right, now with the same timeline, I'm not drawing it anymore, but you can see all we have to do is switch. Let's calculate the interest. If you take 6% divided by 12, you still get 0.005 as your interest. So if we multiply for every month, the principal multiplied by the interest, okay, we're gonna get 7.5. So that is $7.5 is the monthly cash to the first quarter. So instead of 9, we're gonna have 7.5, 7.5, 7.5, and then 15, 15, 15. And then what's 7.5 plus 15? 22.5. And then 22.5, 22.5 falling after that. And then we do a very similar calculation to this. So another way to do is like we already had all these calculated. What we can do is so for 4.5.5, the problem 4.5.5, what we're gonna do is matching the calculation and just twist some of the number to match this new question. Since we already had it here, so you can see this doesn't have to change, or does it? Yeah, that was based on the 4.2%, so I do have to change it. All right, so then the S 3 is supposed to be a future value calculation. This is a 4.42, and then we were supposed to be doing 4.52. Okay, 1.052 raised to the power of 1 over 4 minus 1, and then divided by 1.052 raised to the power of 1 over 12 minus 1. So I guess it won't be identical to the previous question, but still should be a little bit over 3. So to make it accurate, I'll just maintain as many decimal as possible. So that one should be the S. So we're gonna switch that one out for the S. All right, our first payment is not $9, is 7.5. And then we also do not have 4.2%, we have 5.2%. And this one's supposed to be 60 over 4, but our payment is 64 payment instead of 60 payment, so it's going to be 64 over 4. And over here is going to be 64 plus 1, that will be 65. And here is going to be the 64 over 4. And this is 64 payments instead of 60 payment. So you can see we do have to change many of the parameter, but these two questions are really similar. If we're able to keep track of the changes or redo the whole thing, just pay attention to the changes, we will be okay. And that's 5. Quarterly payment, there's no changes there, and that's 5. Okay, and then over here, the payment after the last one, I do have to draw the timeline. This is 5, and that was 64 payment. So 5. And what was the payment? I believe it's not 540. You have to draw your timeline to kind of see it. So let's draw the cash flow for the interest. We start with time 0, and then this is all months. Timeline is being marked out by months. Right, and then here's 1 and 2 and then 3. The first 3, they were all 7.5 and 7.5. 7.5. And then after that, for 4, 5, 6, they were supposed to be 15. Okay, and then how many payment do we get? It's 16 years. So 16 years multiplied by 12, you get 192. So the last one is the 192. But we're having a change of value for every 3 of them. So if you take the 192 divided by 3, and you can see the answer is 64. So it changes 64 times. So you can take the 7.5 multiplied by 64. Yeah, let's see how that is. So it's 480. So the last few payment is going to be 480, and then 480, and then 480. From there, it's kind of like the first, the 4.7.1, the example. There's no change to the cash flow anymore because the principal has stopped increasing. It's for 20 years. So if you multiply 20 by 12, you'll get 240. So the timeline lasted until the months 240 months number 240. And then after that, the cash flow is going to be 480, and that's how we're going to change here. This should be 480, and this should be 480. All right, so these are the two. We would definitely not have the same value, but we can then combine them. And then also, I just calculated the principal, which was 96000. All right, so all we have to do is to have future value 1, future value 2, and then principal all added together. So here we're going to see what was the total value of all 3. Okay, plus the future value 2 is this. And then we're gonna add 96000. That's what I have. Did I forget to combine any? Let's double check the consideration. This example did have the payment of 60 payment, but our 4.5.5 has 64 payments. That is a change. Everything else should be the same. A is 1.045 to the negative. Oh yeah, this one was the problem. Okay, so it's 0.25, negative 0.5. Right, let's correct that. All right, still too large. See if I miss anything else. S and A and oh yeah, the payment after the 480. How many of them? Maybe that was wrong. This is 190, this is 240. After that is 480 the whole time, many of them. The number of 480 payment is going to be 240 minus 90, 192. And number payment is actually 48. 240 minus 192 is 48 payments. So over here, it's not 64, it's 480, 48, right? So we're gonna adjust the number of payment in this payment. So it's not 64, it's 48. All right, so that's how we get, and that's the textbook solution. I'm sorry, it's take me a while to adjust. So if you find the total cash flow, it's this number that you see, and you kind of you can confirm each calculation, see if we are on the same page. I didn't really calculate individually. I kind of push them all together into a one big calculation. Once you get here, you can then start calculating the implied interest rates. It takes me a longer time. Implied rates. The calculation the textbook was using the BA2 plus calculator, and we can do that the same way. What you're gonna do is, let's see, what was we're gonna do? You put in 15500 and then make it negative, and then we push enter the key, the enter key, and then the down arrow, and then that is setting the cash C0 equal to negative 1500, and then we would put in the done, and then we have 1500, then plus or minus key, and then you enter, which set your first cash flow as negative 1500, and then push the down arrow, and then we can enter the number of payment, which is frequency. So you put the frequency equal to 63. So the 1500 negative is being repeated 63 times. Actually it's 64 times because, but your first payment is already 150. So you're paying 1500, then you pay 63 of 1500. That actually counted for 64 times. And then you have a couple of times there's no cash flow, so you're gonna put 0 as your cash flow. Well, after you enter, and then you're gonna have to move down, push the down arrow, and then you put in 0. You're gonna enter 0 as another cash flow, and then you put in the down arrow again, and the number of payment of $0 is 16. And you enter to make sure that 16 is being entered as a frequency, and then you push the down arrow again, then you're going to enter this number that we just find out as the future value, or as the next cash flow. So enter this as your cash flow, and then you're going to type IRR key, push the IR key, and then push CPT to let it compute. Then you'll see your interest rate should be calculated as the 1.43 to 687.69 are going to be your interest rate, and this is a quarterly interest rate. And then from there, you're gonna calculate the annual interest rate. If you already have your quarterly interest rate, to find the annual interest rate, all you have to do is go 1 plus Q, the quarterly interest rate, and raise to the power 4 and then minus 1. That will give you the annual interest rate. And that will be it. I think that's all the solution for the number 4 and the number 6 for chapter 8 homework assignment. I hope that works out.